Welcome to Rges Pre-Algebra. This is lesson 5B, and we're going to be covering in your book 1.24 through 1.26. The first concept is multiplying and dividing by powers of 10. This is actually a very simple concept. If we were multiplying, let's say we want to multiply 0.5184 by 1,000. Well, we count here, this is my power of 10, of course, and I count 3 zeros. So I want to make this number larger by 3 places, or 3, so if my decimal is there, I want to move it to the right to make a larger value. So 0.5184 now becomes 518.4. What if instead I had wanted to multiply the original number by 100? Well, this is 2 places, so now this time I will move it over from the original decimal place over 2 places, getting 51.84. And that's as simple as it gets. If you have no decimal, or if you have no decimal at all to begin with, let's say I want to say 75 times 100, I'm still going to, 75 is the same as 75 point, so with a whole number you would just place the decimal, and then again you would move it over 2 more places, so that would look like 75, 2 more places before I get to my decimal point, adding in the zeros. You do or do not, you don't have to write the decimal point at the end, then you could just write 7,500 or 7,500. Okay. If you are to divide, you are making the number smaller by the same amount. Let's say I say 618 divided by 1,000. I have 3 places, or 3 zeros, so I want to move my decimal over, which is really located right there, and I want to move it over 3 places to the left to make a smaller number. So I would have 0.618. If I had 3.15 and I wanted to divide by 1,000, or let's say divide by 100, let's do something different, I need to move my decimal place over 2 places to the left to divide, meaning to make a smaller number, so now I get 0.0315. And that's all there is to that. The next concept is when I have long division with decimals, and now what I want to do is make my divisor have no decimals in it. So I would want to multiply this, or take this over 2 places to the right to get rid of the decimal point out of the divisor. If I do it here, I must do it here. So this now becomes 7.56 divided by 18068.4. Oops, I should have taken it out of there. Let's do that. There we go. That's what I intended. So we've moved the decimal point out of the divisor by moving it over in the dividend. Okay. Then we would just divide like normal. The first number larger than 756 would be this, and so I'm looking at how many times that goes in. It goes in twice, same like we've done before. It'd be 15, 12, subtracting, I'm going to get 4, and so I went ahead and finished it out here. Notice what I've done now is I've put my decimal straight up from where I've moved it to. Now I did not have to rewrite it here. I could have just done this up here and place the decimal, and then I'm treating it like a whole number. Again, let's do one more. If I have 6.23 divided into 1,177.47. Again, you remove the decimal out of the divisor by. So I went ahead and finished it out over here, and notice that you do put your decimal up above where you moved it to. Very important. So you don't have to rewrite the problem. I'm looking at a new one over here, 6.23 divided into 1,177.47. And notice I need to move it out of the divisor by moving it over 2 places. Move it over 2 places here, and just go ahead and place the divisor, or the decimal point, right above. And then you can go ahead and work the problem. I'll do it quickly offline. So the key to this idea then, long division with decimals, is simply to move the decimal out of the divisor, move it out of the dividend, and place it up above in the new location. Then treat it just as you would whole numbers. Now, as long as we're at this section, this would be 1.25. I would like you to go to your text for a minute. Let's look at that problem solving. Number 1. Problem solving number 1 says Michael Hendricks earned $232.10 for working 27.5 hours. How much would he earn if he worked 40 hours? Okay, here's my first word problem. So if I have $232.10 in 27.5 hours, there's a couple ways I could solve this, but the way that you are most familiar with right now would be to do it as a 2-part problem. First, I would divide. I'd take the amount of money I earned. I would divide it by 27.5. That gives me how much I earn per hour, and then I would go back and multiply that amount by 40 to give me how much I would earn in 40 hours, and hopefully that's clear to you. In the second one, it says you've traveled 580.5 miles in her compact car on 13.5 gallons of gasoline. How many miles per gallon did the car get? Well, this is not a complex problem. This has only one step. If I were to divide the number of miles by 13.5, I would get the number of miles in 1 gallon. And so it's just a simple division problem. I see nothing else complicated on that lesson. Now let's go to 1.26. This is decimal fraction equivalencies. And notice at first, they're on page 38, they're giving you a chart. And if you do not know these already, or the ones you do not know already, I want you to learn. So we know that 1/2, hopefully, is 0.5. I know that 1/4 is 0.25, like a quarter, a fourth of a dollar. 2/4 is the same as 1/2, so we have that above, which is 0.5, and 3/4 is like 3 parts out of a dollar, or 3/4 out of a dollar, 0.75 cents. So hopefully our fourths is something you're very familiar with, as you are this. Now the next group has to do with fifths, and 1/5 is 0.20, 2/5 is 0.40, 3/5 is 0.60 or 0.6. I don't really have to have an O there. 4/5 is 0.8. And of course 5/5 would be a whole. So we're counting by twos. 0.2, 0.4, 0.6, 0.8 to get our fifths. Okay. So that would be one I would expect you to know pretty easily. The next one, 1/3. 1/3 does not come out as an even decimal. It's 0.3 repeating. 2/3 is 0.6 repeating. For 6, I would have 1/6 is 0.16 repeating. Notice it's only the 6 that repeats, so it's 0.16666. Okay, 2/6 is the same as a third. 3/6 is the same as a half. 4/6 is the same as 2/3. So you've already learned all of those. The only other one to learn is 5/6, which is 0.83 with only the 3 repeating. The one, let's see, there's 2 more sections. One is what they talked about in the example up above, anything divided by 9. Let's say I have 4 9ths. We can memorize these. This would just be 0.4 repeating. If I had 7 9ths, that would be 0.7 repeating. And if you want to know why that works, just go ahead and divide a couple of those out and that will become clear to you. The only other one is 8ths. Let me go to the next section. So this would be 0.125. 2/8 is 1/4. This would be 0.375. 4/8 is 1/2. 5/8 is 0.625. 6/8 is 3/4, and 7/8 is 0.875. Notice what's happening here, okay, is we have 2575, 2575, so that will help you remember that. So then how would I convert a decimal or a fraction to a decimal? If I had 7 3/5, for instance, I would write my whole number and put my decimal, and I'm only worried about rewriting the decimal part. Well, I know 3/5 is 0.6, and that's all there is to it. Most of these they've given you, not all of them, but many of them have been things you've memorized here. For instance, 5/3. Once you've memorized this list, convert this to a mix. That would be 1 2/3. Write the whole number down, put a decimal. 2/3 is 0.6. So it just works just like that. What if it's something you haven't memorized, like 9/20, for instance? I haven't memorized that. Okay, well, again, we could do this with ratios. Later on, you might find that even easier, but right now, all you do is read this like a division problem. It says 9 divided by 20. So go ahead and put your decimal in there. You're going to put your decimal right up there. You need 90. 90 is the first thing bigger than 20, right? And it's going to go in 4 times for 80, with the remainder 10, and it's going to go in 5 more for 100. Okay, so 9/20 is the same as 0.45. Looking at your problem solving on page 39, number 1, Emma Mitchell spent 5 hours on Thursday preparing for a history exam. What fractional part of the day? So make that a fraction. 5 hours out of how many hours are in a day? And then they also want you to make it to a decimal and round it. So you can do the rest of that by the conversion I just showed you. 5 divided by 24. Of course, you would have to add an extra 0, so I make sure I put my decimal there and continue on until you get it to the 10,000ths place. Number 2, during several baseball games at Athens Christian School, Jack Sellers had hit 12 hits in 35 times at bat. What was his batting average? That would be the number of hits with the times at bat. So they did that part for you. It would be 12 over the hits over the times at bat, just like that. Change that to a decimal, rounding to the nearest thousands. And again, you know how to do that. Noah Bowman, who plays for Grace Christian School, had 23 hits and 40 times at bat. So I've already told you how to find the batting average in the last problem. So you can do that. I want you to skip problem 4. Looking down at the sharpening skills, I don't see anything you should have trouble with. I do want to emphasize, make sure you remember to memorize those decimal conversions before you get to class.